So let's go over object-oriented programming, the theory side. So if I bring up this document which I created for this video, so there's I'll just go do a brief overview of the object-oriented programming. So there's like three pillars of object-oriented programming that are considered as the three pillars. There's encapsulation, inheritance, and polymorphism. So I mean, for any junior programmer or someone who's starting out in programming, those words can cause a lot of anxiety or fear. You don't really have to worry too much. It's not that much of a big deal. It just encapsulation is they're quite straightforward concepts. Encapsulation just means that the object, the internals of the object are not visible to the outside user, so they're encapsulated. So you only show, for example, in the object that you create, you only expose what the user needs to use. You don't need to show the internals of the object. The reason is that you can easily change the internal implementation without impacting the user. So if, let's say, version 1, you release version 1 of the software and it's object designed in an object-oriented way, then what will happen is then the user will start using that code. They'll start writing code to use that software that you have released. And when you release version 2, let's say there's a lot of changes that you made on the internals of the object. Now, if they use the same interface, if you keep the interface the same as the previous version 1 that you released, then they will not be impacted. They will get a better version of the software, but their code won't break. So that is the advantage of encapsulation. You hide the implementation details. You only expose what the user needs to know. So that is the first pillar of object-oriented programming. The other concept is the other pillar is inheritance. Inheritance just means that you can inherit from objects. So let's say you have a parent object and it has some kind of functionality, then you can actually have other objects that inherit from that object. So you're inheriting the functionality and some of the data members and some of the functionality from that object. You're inheriting that. So you don't have to rewrite it. So if you have like function A and function B and field C and field D in the parent object, if you derive or inherit from that parent object in your object, then you will automatically get those functions or methods and fields in your object. So you don't have to rewrite that. You inherit that. It's like you're inheriting money from your parents, for example. So it's the same concept, but at the level of objects. And polymorphism just basically means that an object can have many forms. So, for example, it's kind of tied to inheritance. Like for example, if you go to the example that I have given here, so you have the animal, the parent object, and it can have many forms. So you can have a cat, and you have a dog, and so forth. So this diagram actually shows these principles. So you can't actually see the encapsulation here, but you can see that the other two mentioned here, the inheritance and polymorphism. So you have the animal parent object and the animal parent object. Then you have the cat and dog objects, which are derived from the animal object. So these two objects are actually inheriting from this object. So whatever functionality in data is available in this one, it'll be derived or inherited in these two objects. So it's going back to the polymorphism, the many forms. So this is an example of polymorphism. So you have this animal object, and it can take on the form of a dog or a cat, and so forth. So that is the idea. So in terms of the programming, so if you have a dog object which derives from the animal object, you can pass this dog object to a method that accepts either an animal or a dog, right? Because this derives from the animal, you can pass it to a method that accepts an animal object or a dog object. Same with the cat. So if you have a cat object, you can pass it to a method that accepts an animal or a cat. So that's like a polymorphism in practical in real terms. So that's like a brief overview of object-oriented programming concepts. So going back to, if I go back to the this one again, encapsulation is, you're hiding the internals. Like, so for example, in these ones, you only show what the user needs to know. They don't need to know the internal implementation. Inheritance is, what I said before, how you can inherit functionality from parent object. So in this case, the parent object will be the animal, and the deriving objects will be the cat and dog. And polymorphism is the many forms which I just mentioned. So this is just a very simplistic diagram. You can enhance this. You can have other types, like you can have in between objects like mammal, reptile, and so forth. So you can expand on this and improve it even more if you really wanted to. But this is just for this exercise. I have kept this very simple. So going to the code. This is some code that I wrote to demonstrate this one. So this is basically a Visual Studio 2015 project. It's a .NET project. You can download Visual Studio Community for free from the Microsoft site. So if you go to the Microsoft site, you can download that for free. And this solution. So this solution, I will just give you a brief overview. So if you expand the solution, you can find that document that we just looked at, oop.pdf. This is some licensing from the copyright information in there. So in this solution is called animals, and it's got 4 classes. It's got the animal, the base class. We were looking at that, the base object that we were looking at in the diagram. The app.config is the configuration, the application configuration, which I won't go into. If you're interested in .NET, you can look into that and find out what the configuration file does. Basically, it's the configuration for the application, and it informs the .NET runtime, what type of, how to handle that application, and what configuration information is relevant to that application. Then you got the cat and dog, which are derived from the animal, and you got the program which is the entry point. This is the starting point. So this is a console application, and this being a console application. So a console application. So you get different types of applications. You got Windows applications. When you run the application, it's like Microsoft Word, for example. That's a Windows application. Console application is like DOS. DOS, you type, you see a black window and there's white letters on it, and you can type commands to the console, and the console executes those commands and gives you some kind of output. So that's a console application. A Windows application is like a graphical program, like Microsoft Word, Microsoft Excel, those type of programs. But in this one, just to keep it simple, I have used console application. So this is the program.cs. So .cs means C#. So it's a C# file. So it's a class. So I'll just go over this so that in case you don't know what these lines mean, in case you're a complete beginner. So using system, this is like a namespace. This is something that you import from the .NET framework, and this allows you to use the functionality in this namespace. Namespace it's like a way of organizing code. So this namespace has certain functionality. It's got some classes in there. It's got quite a lot of classes that belong to the .NET framework, and you can utilize those classes. So for example, the console class. The console class, the system, see how it says system.console? So this class has a readline method that allows you to read input from the console. And there are other methods like console write, and so for example, if I click on this one, so there's other methods like you can actually write to the console. So you can write with this method, you can write commands to the console, write text to the console, for example, output text. So this going back to this class, this program, program.cs class. .cs, as I mentioned, is means C sharp. So this one is, as I mentioned, as a system namespace, has a functionality such as the console. And I have declared a namespace called animals, right? So because this is related to animals, and I'll just use that as an example, but you can use any topic you like. But just to keep it simple, I have used this example. And the project itself is also called animals. So if you look at the project, it's got that one there. And I have used the namespace animals as well. So the namespace basically means it's a way of organizing code into it's like a folders. If you think of like a folder as a way of organizing files, a namespace is like a folder, but it's like a virtual folder. It's not really a folder, but on the hard drive, the classes will be placed in a folder actually. But in terms of the namespace itself, it's like a way of organizing code. So inside the animals namespace, you will have animal.cs, cat.cs, dog.cs, and program.cs. So all these classes. So if I open up the animal class, you can see it's got the same namespace. If I open up the cat, again, it's got the same namespace. If I open up the dog, it's got the same namespace. So that means that all these classes, the dog, cat, animal, and the program, they all contained inside the same namespace. So you can refer to each of these without anything special. See how I have declared the animal object here, animal cat. There's no. I don't need to do anything else because it's in the same space or namespace. I don't have to do anything special. But if I want to use the console, then I have to specify that I want to use that namespace, see, using system. So if I actually comment this out, see, the console just goes away. Now if I try to compile that, see, what one failed. Where the errors? Error list. See, the name console does not exist in the current context. So console, it's having trouble finding console because it doesn't know where the console is coming from, because it you have to tell it, check in this namespace, this system namespace, which is part of the .NET framework, to check there to find this console object or class. But with animals, you don't have to worry. You don't have to say, I don't have to say animals dot animal, because so this is a way of, again, see, the animals namespace. I don't have to. I don't. So this is like. So let me show you something. So I can use this statement, or I can do this. I can actually add it to the object itself. So now it knows, okay, it's part of. Now if I build that, it'll work. See, it succeeded. There's no issues. It knows the console is coming from the system namespace. I can either do it there, or I can do it from here, and then it still knows, okay, because I've said using system namespace, it'll look for console in the system namespace. Now in terms of the animals, I can just use the animal object straight as is. I don't have to say, I don't have to go like this. I don't have to go using animals, because I'm already there. I'm already in that namespace, and I don't have to do this. I don't have to go dot, like that. See, like even if I do a dot, it shows the types that belong to that namespace. See, animal, cat, dog, program. It shows it there. So, but you don't have to do that because it's already in the same namespace. The program, the program class is already in the animals namespace, and these are also in that namespace. So I don't have to specify that in a special way. It's already those classes are already there. So I don't actually need this statement. Can get rid of that. I don't need to do what I did before. I don't need to do that. I can just use it as is. So that's what a namespace is. It's a way of organizing code. So as mentioned before, This is the entry point to the application. This is the first code that gets executed, and this is the entry point. So this is where the program starts executing from, and these are arguments or arguments or data that's passed into this method. So this is actually a method. Method is like a way of a function. It's like function. It's a way of performing work. And these args are actually arguments that are passed in. So this is a string array, right? So it's a type string array. That means it's a string, but it has multiple cells in that string. It's like a collection of strings. So that's what an array is, and it passes in this collection of strings from the console into this program, so you can make use of it. So, for example, when you execute this program, let's say it was animals.exe. It was compiled as animal.exe. You can say animals.exe space, and then you can provide the parameters. You can look into it in more detail later, but I'm just giving just a very rough overview so you can get an idea of what the code is doing. And then what I have done is I have actually declared an animal object. I have declared a cat object and a dog object. And this code I have commented out. That's why it's in green. See, the slash is at the front. It just means that that code has been commented out. And there's a console read line just to pause the execution. Because if this line wasn't there, now if I try to run this one, see how the window comes and goes away straight away? See, it disappears. That's why. So you have to actually add this line. So if I uncomment that and run this again, see how it waits. Now it's waiting for input. So if I press a key, then it gets the input and straight away it stops execution. But anyway, let's not worry about that. So this is just a to show what the program is outputting, right? So this is what the program is outputting. So it's creating an animal, it's creating a cat, it's creating a dog, and so forth. So let's go into the details of that. So let's find out what's actually. So let's go back to the to this drawing. As I mentioned, the animal is at the top. In the going back to the principle, the encapsulation is hiding the details, and the inheritance. This is the example of inheritance. You have the animal as the parent object, and then you have the cat and the dog, which are deriving from the parent object. So these objects inherit. These objects inherit from animal, and animal is the parent object, and these are the deriving objects. Because they inherit from the animal. So what do they inherit? They inherit the functionality and the data. So that's what inheritance is. Polymorphism is the many forms. What I mentioned before. So going back to the code. So let's have a look at the animal, the base class or the parent class. So if I have a look at the animal, you can see that it's got the namespace, same namespace as before. So it is a class. So class just means it's a compilation unit. So what that means is it's like a type. It's like a type that you define. So you're creating your own type. It's like a blueprint, and that blueprint gets created into an object. So this animal class. This is the definition of that class. This one gets, when you say new animal, what it's doing is it's allocating memory for this class so that it can become an object. And this reference, this word is actually a reference. And this reference will hold an instantiated object of type animal in this reference. It'll hold an instance of that object, which is based on this animal class. So whatever methods and data are here will turn into an object and get assigned to this reference. So it's the same with the cat and same with the dog. It'll allocate memory, and it'll create a new cat, and it'll create a new dog, and it'll create a new animal. It'll assign it to this reference, which is of the same type, right? So you assign the same type of object to the same type of reference. That's what you do. But as I mentioned before with polymorphism, you can actually do something else. I can actually assign a cat to the animal, or I can assign a dog to the animal. The reason is the cat derives from animal, and the dog derives from animal. So it's the inheritance. So this colon there means that the dog is deriving from the animal, and the cat is deriving from the animal, is inheriting functionality from the animal. So what is the functionality that it is inheriting? So going back to the animal class, you know uh, the so this is the functionality that it will inherit. So these methods, so do you see this move method here, display info, and these other methods, it will inherit some of these methods and some of these fields. These are fields, right? These are fields. This is a field. So field is basically a piece of memory that holds information of a certain type. So this one is an int field. Int means integer type field. So that has, you can hold numbers. This is a color field, and this is the constructor, and these are actually methods, right?